My name is Rajdeep Dua, and I'm handling a couple of engineering teams at Salesforce. I spoke at a keynote here a few years ago, and things have changed quite a bit. So today we are going to talk about generative AI in enterprises. We had some very interesting keynotes, one on from OpenShift and one from Neo4j. So this presentation is not like deep in the woods in the code. We are going to step back and look at the overall landscape and where Gen AI is going in general and how our enterprise is adapting. What are the challenges we are looking at? So all of us are quite familiar with the rise of Gen AI, right? I don't need to give gyan here on where it is going, but the important thing to note is that we are looking at an annual growth rate of 42%. And this AI, Gen AI market is going to be $1.3 trillion market in a few years by 2032. This means that a lot of investment is going into infrastructure, platform, and applications around Gen AI. And I'm talking about both B2C and B2B. This also means that it's going to add a lot of productivity enhancements, especially in the enterprise workloads. This means we are going to look at a productivity improvement of about 3.3 points, right? But all of us have heard about shadow IT, right? Now we are looking at shadow AI. Developers, they want to perform and they want to be productive. So they are not waiting for the traditional IT department to roll out Gen AI tools. They are going to get their own tools by circumventing IT, right? And this means that a lot of CIOs are worried about the security loopholes and privacy concerns and their proprietary data getting leaked. So what are the key trends? According to the Forrester prediction, while OpenAI and some of the models from Bard and Gemini, they have been useful and they have been popular, but the future looks open source, right? Open source is going so fast that everybody is worried. But it means it's good news for us developers. It means that we have a chance to look at these open source and see how we can use them without having to pay the top dollars to companies like OpenAI. This also means that we have to invest in our own platforms to host these models. And 40% of the enterprises are already looking at these models, how they can help improve their productivity. But the problem is, how do you remain compliant? Compliant with some of the policies which are getting rolled out within the enterprise and also at the government level. We look at some of the AI governance models which EU is rolling out. 60% of these workers are going to use Gen AI whether you like it or you don't like it. I think we love it, but our IT department does not like it. What does it mean? As I said, there's a huge amount of investment going into Gen AI. This also means that at some point in time, we have to figure out the ROI. How are we going to find the product market fit, right? So much VC investment is going into startups. It means that at some point in time, these startups have to start making money. So time will come when people will start asking, hey, how do you monetize all these boutique startup use cases, right? They have to merge with the enterprise use cases. The cost of inference is still very high. If you look at traditional models, whether they are like normal machine learning models or deep learning models, they are still much faster and cheaper to get the prediction out from as compared to a LLM, right? How do you optimize it? Then prompt tuning has become very popular. There's a whole new profession of prompt engineers, but people have realized there are limitations, right? Which means that we have to move towards fine tuning. And we saw one simple demo of fine tuning, but the challenge is fine tuning is not easy, right? And I have seen use cases where after fine tuning, the model was performing even worse than without fine tuning. So how do you go there? Then the rise of RAG, right? We talk about retrieval augmented generation. A lot of enterprises have data logged into their databases and their own data lakes. They want to use that data, but they don't want to send raw data to large language models, which are traditionally not multi-tenant. So how do you circumvent these use cases? And then, while the large language models are popular, they are easy to use, easy to adopt, but the future might be smaller models and specialist models, right? Which will make it easier to deploy, to manage, to update. And models themselves are becoming multi-model. They started with text-only model. Now we are looking at the same model which can intake an image, a video, a speech file, and also predict the same output, right? And you can overlay all these kind of various inputs together into a same prediction. And last but not the least, the AI governance. Government at some point in time is going to come in and start looking at high risk applications and how do we reduce this risk. Which industries are early adopters? From the graph, you can easily see that technology, media, and telecom is at the forefront, along with financial services. So at Salesforce, we have a bunch of financial services products, but there are a lot of challenges which remain. Banks and financial institutions, they are regulated industries, right? Which means that this data cannot go out. If it goes out, they want to host their own models, or even if they don't want to host their own models, they want to make sure there is a trust boundary around it. There is enough obfuscation happening before you can even get the data out. And within these verticals, which functions are early adopters? Marketing and sales are definitely the early adopters. That is where I think we see a lot of momentum, especially around how do you generate sales summaries? How do you convert these sales calls, which are speech only, into text and analyze and figure out the key trends, whether it is sentiment, where your opportunity is going, whether your lead is going to close or not, the use cases like opportunity scoring, lead scoring, and so on. While they were being solved using traditional AI, people are figuring out some of the generative models could be leveraged, especially around summarization. So this is a typical life cycle of a Gen AI application. So this is slightly different from the life cycle of a normal software application. The difference is in the middle, that red boxes which you see. So defining a use case is very important. It's like one of any software development life cycle, right? First, you need to figure out, does this use case even need generative AI to be used, right? So I have seen people saying that, hey, can I use it for classification, recommendation, regression? The answer is no, right? Gen AI, they are specialist models. Don't use them like a hammer on every nail. So make sure that you have the right use case for which Gen AI is the right fit. Once you have the use case and the process figured out, what kind of model you want to use, right? What are the trust boundaries? Is it a high risk application or medium risk application? Is it a regulated industry or not a regulated industry? That is where the choice of model becomes very important. Especially, I'll give you an example. We are rolling out few Gen AI applications for banks, and as we go into EU, we have to figure out those LLM models have to be, they are hosted in EU. So think about all those things, right? And if you're choosing a open source model, especially from Hugging Face or any other hosting solution, you are not going to serve it in production from Hugging Face. You have to figure out the whole serving infrastructure. There was a pitch from OpenShift and Red Hat guys, but it's a non-trivial problem to solve. And once you've figured out the model, then three elements come into picture. Is prompt engineering good enough? Or do you need fine-tuning? Don't jump the gun on fine-tuning, but evaluate it. So evaluation metrics, we have specialist evaluation metrics for Gen AI models like Rogue and Blue, and there are new models coming out, but it's not easy. So the key is for LLM evaluation, make sure the PMs are providing you the right utterances against which you are going to test your output. And make sure you align with the human feedback. This means that even during development, you have to keep your PMs involved. Once you have everything laid out, and these models and the predictions they are emitting, they are not going to remain in isolation on a screen, right? It has to interweave with rest of the workflow, especially in like CRM use cases. They have to be there in the summarization page or in some dashboard, or we have a new kind of applications which are like conversational applications, right? Bots have been around for a very long time, but the challenge with bots was that they are like all slot based. So now we are moving from slot based bots, which needed a lot of custom training for on intents. Now we are moving to LLM based bots, which are much smarter. So we have this whole rise of copilots. I'll talk about it in a second. So make sure you have the output from LLM weaved very nicely into your whole process. So Gen AI in financial sector is a very interesting use case. While they are the early adopters, their focus is not on productivity improvement for revenue growth. Their focus is productivity improvement for cost reduction. Because for them, IT is a cost center. It's not a revenue generating function. But if you look at healthcare, the scenario is totally different. It's a very complicated, regulated industry, but lot of scope. If you look at drug discovery, you look at risk mitigation, if you look at resource allocation, especially we have a healthcare product where we are looking at scheduling of doctor's appointment, scheduling of clinical visits, especially if you're doing clinical trials. It's an industry in itself. Choosing the site to do your drug testing. So all those things can be optimized in a much, much better manner with Gen AI. And plus, there are specialist models being built just for these use cases, like diffusion models, especially for image reconstruction, image generation, and so on. See, a lot of these models are today being used or will get used in these MRI and CT scan machines, right? And to fine tune those models, there are not enough input data available. That is where Gen AI will be used to generate that synthetic data. Especially all these models, if you look at diffusion models, GANs, and variational autoencoders, all three will be used for generation of synthetic CT scan images. And then for clinical decision support, we have transformer models, which can do image to text to text, and so on. For doctors to do diagnosis, summarizing the whole input is very important. And that is where these evidence-based clinical models come into picture. So, few other things I wanted to touch upon. As I said, a lot of data is in the enterprise databases and data lakes. People are not going to expose that data to large language models. That is where vector search, embedding search comes into picture. So you basically, the use case is, so you convert all your textual data into chunks, convert it into embeddings, store it in vector databases. So you search, when a query comes, you search for the right chunk and then combine that chunk with the prompt and then send it to the LLM. That is how you get the summarization. But the challenge is traditional vector search or traditional RAG is not good enough. The search queries are complicated. So that is why we have this concept of advanced RAG. So these are early stages, right? Query rewriting, post-retrieval processing, augmentation of the search responses. All these things are, I think we can spend a couple of hours just on this topic. So I'm just trying to say that this is how enterprises are overcoming the fact that they don't want to send their proprietary data to large language models. So I talked about conversational AI. The rise of copilots is important. Why it is important? We are moving from point and click UI to conversational AI. And LLMs again play an important role. And just imagine LLM combined with vector search and RAG, it's a deadly combination for any enterprise. But people are still figuring out how do you basically get it out at scale? How you can replace all your BPO and backend processes and all those people with automated agents. They can be done for the first layer, but eventually they will go down into tier 2 support, tier 3 support. So last thing I'm going to talk about, we have very few time, very small amount of time left. AI governance is a very important topic. We could have a 1 hour lecture just on AI governance. Governments are not going to sit quietly. If you look at EU, they've already come out with this pyramid and they're going to classify the AI applications into high risk, unacceptable risk, and limited risk applications. They don't worry about minimal risk applications, but applications which are going to decide who is going to get that next job. Applications which are going to decide which patient gets prioritized. They are going to review all of them. For high risk applications, actually, they have come up with a workflow. And believe me, each of these applications have to be registered with EU central body and they will review. And if they find there is a bias, they are going to come back and make sure that you change that application. With this, we are coming to the end of the talk. To summarize, Gen AI is for real, but these are early days of adoption. A lot of challenges in front of us. AI governance is a big issue. So LLMs are inherently not multi-tenant. So make sure you guard your data, obfuscate it before it goes to a large language model. With this, come to an end of this talk. Again, we'll be out there. You can reach out to us and really excited to be here. Thanks again for attending the keynote. Thank you.